Hi there. Today I'll be presenting an important concept in software testing called white box testing. This allows us to peek inside the system, inspect the logic, and verify how each part works. Let's begin by understanding what exactly this approach involves. The 6 steps to understand these concepts are introduction, benefits, challenges, common techniques, when to use, and the real world example. The first step, introduction. So, what exactly is this white box testing? It's also known by other names like clear box testing, glass box testing, or structural testing. This method gives the tester complete visibility into the internal code, logic, and structure of the software. White box testing isn't just about checking what the software does, it's about understanding how it does it. That means we examine loops, branches, conditions, data flow, and more. It's mostly performed by developers or testers who have programming knowledge, especially during unit testing stages. The features include our code visibility. This is a core aspect. The tester must have access to the source code so they can analyze and trace the flow of logic inside functions and modules. Internal logic testing. This testing evaluates how the code behaves internally, how control flows through conditions, loops, branches, and method calls. For example, is the if statement working correctly? Are all loop terminating as expected? Then, the test coverage. This is a crucial step in the white box testing. We measure how much of the code has been tested. The key types include statement coverage, branch coverage, path coverage, and condition coverage. Now, moving on to the second step, benefits. Why is white box testing important? Let's go through the benefits. Through bug detection. Since we dive deep into the code, we can catch bugs that are buried deep, especially logical or calculation related errors that black box testing may miss. Code optimization. Developers can identify and eliminate redundant or inefficient code, leading to better performance. Early error detection. Because this testing is often done at the unit level, errors can be caught and fixed before the application progresses to later stages of development. That saves time and money. Step 3 are challenges. With great power comes some challenges. So, the challenges faced by this are it requires expertise, a strong understanding of programming languages, algorithms, and architecture is needed. Not all testers may have this skill set. Time consuming. Testing every logical path, loop, or condition can be very detailed and takes time, especially in large code bases. Limited user perspective. Since white box testing focuses only on internal logic, it doesn't test the application from a user's point of view. That's why it's often used alongside black box testing. The next step is common techniques. There are a few important techniques used in white box testing. These ensure comprehensive validation of the code. The first technique is statement coverage. We ensure that every line in the code runs at least once during testing. This helps in verifying that no line is skipped. Next is the branch coverage. This checks every possible outcome of each decision. For instance, if there's an if-else statement, both the true and false branches should be tested. Path coverage. Every possible flow or route from start to end in the code is tested. It's more detailed than branch coverage and can be tricky in complex programs. Condition coverage. This ensures that all parts of a compound condition are tested separately. Together, these helps to ensure that the logic is fully tested and reliable. Step 5. When to use. Now, we should understand when and where should we use the white box testing. Unit testing. This is the most common case. Developers test individual functions or methods during development to ensure they behave correctly. Integration testing. Once multiple modules are combined, we use white box testing to ensure they communicate and work together as intended. Performance and security testing. Since white box testing explores the inner working of the application, it can identify performance bottleneck and potential vulnerabilities in the code, such as unsafe memory, usage of it, or insecure logic. The last and final step, real world example. Let me give you a relatable example so that you can understand the concept in a more simplified and easy manner. Suppose we have a simple function to calculate the square root of a number. A white box test approach would first verify if the function handles edge case properly, like a negative number or 0. Examine the loop logic or recursion used in the calculation. Check if the return value is accurate and precise. Confirm that invalid inputs are handled gracefully without crashing. So, rather than checking the result, white box testing looks at the step the function takes to reach the result so that the result can be attained without any error. Now, as a conclusion, I'll just wrap up what white box testing is and the essential of the software development process. First, it ensures code behaves correctly, efficiently, and securely from the inside out. While it demands in technical skill and time, it greatly improves software quality. Thank you for your time. I hope this session gives you a clearer understanding of what white box testing is. Thank